take it away.
Hi, everybody. We are Team 4, High Voltage Club, and we are the Bar Bots. Our team is comprised of Valerie Ruiz, Luke Summerfield, Michael Kane, and Rainer Ballesteros. Now, in general, most businesses, including the hospitality industry, faces some challenges related to labor shortage and reliability. Our automated solution creates a safe and efficient bar operating system. Our customers direct are including bar patrons, bar staff, and bar owners. Indirect customers include suppliers, law enforcement officers, cleaning crew, and live entertainment groups. Some of the design requirements that we did think about in this process include, but not limited to, mobility, functionality with limited maintenance, cost effectiveness, accuracy, its ease of operation, and visual presentation. And here's our first robot design.
First up is the security bot, designed by me, Luke Summerfield. The design is pretty simple, has 4 wheels for mobility, 2 ultrasonic distance sensors on the front for impact avoidance. It also has 1 large control arm actuated by a servo for entry control, and 2 drink tamper tablet dispenser areas on the left and right side. Next slide. This is just a list of the main components that go into the design. Includes 3 ultrasonic distance sensors, some force sensors, camera module, light servo motors, heavy servo motor, and 4 DC motors. Next slide. This is a basic circuit design for the robot. It includes the force sensor and the ultrasonic distance sensor, which are connected up to 2 servo motors that operate the control arm and the tablet dispenser. The Arduino has to be supplemented by a 3-volt battery source, which is externally mounted. Next slide. This is the basic pathfinding logic map. The robot moves on its own forward. If the ultrasonic distance sensor picks up anything, it will rotate for 3 seconds in the left direction and then start moving forward again and do that until there's nothing blocking it. Next slide. This is the ID scanning. So the ultrasonic sensor is tripped by the presence of an ID card. It takes a photo. The photo is then processed. The date is read, and if it is lower or higher, the robot acts accordingly. Next slide. So we'll run through the demonstration. I will share my screen. A quick demonstration here. We have the force sensor. We have the force sensor here, which after a certain amount of pressure, which is a little bit less than 2.5 newtons, the servo rotates 110 degrees to drop a tablet, and then rotates back when there is nothing there. The ultrasonic distance sensor will actuate the servo on the bottom 90 degrees at 5 inches. And this is for the this is to simulate the presence of an ID card. And that is the security robot.
And next robot.
So we've got the bar back robot, and I'm going to be showing you the purpose, mechanical design, wiring diagram, a parts list and cost breakdown, activity diagram, and the demonstration to conclude. Next slide. So the purpose of the bar back robot is to maintain inventory levels, deliver items from the supply room to the bar, patrol behind the bar to analyze inventory levels at the bar, and to report inventory levels to the central hub. Next slide. So the robot's design is a robot kit that is purchased from the Elegoo website. It is equipped with the line tracking module in the lower portion of it, the ultrasonic sensor module on the front of it, the camera module up top that includes 2 servos that allow for biaxial rotation, and it includes shock absorbers for the drivetrain and DC motors to power the drive wheel. Up top, there is an area allocated for the transport of goods. Next slide. So here you've got the circuit design. It is an Arduino board, which is the Elegoo Uno R3, and an expansion board on top of it. And the expansion board is what all of the components are connected to up top. In the middle, you can see the assembled circuitry. Next slide. Here's the wiring diagram for how all the components fit onto the expansion board. As you can see, there's the servos, the 2 motors, the line tracking module, the cell box that houses the lithium batteries, the ultrasonic sensor module, and the camera module. Next slide. So the ultrasonic sensor module, it's going to measure between the distance between objects to allow for the safe navigation through the bar. A line tracking module to ensure that the robot follows the direct path to the supply room and back to the bar. Servo, like I said, allows the camera to move in a biaxial direction. Motors for the drivetrain, and camera on top for a visual feed, and LED lights to indicate the status of the robot. Next slide. So here's a parts list. Like I said, the robot tank was purchased as a kit for a total of $129.99. Next slide. Here's the logic that was provided for the obstacle avoidance functions, the line tracking, and the movement of the robot. Next slide. So here's a demonstration of the obstacle avoidance. If you hit 2 on the remote control, then the obstacle will move forward until it senses an object in front of it, in which that case it'll turn to avoid the obstacle. And next slide. And this is the live view from the camera that is mounted on top, and the view from the app that can also control the robot. Next slide. And here's the reference list for the robot kit. Next slide.
Great, and I have robot number 4, the Atmosphere robot. It's designed to all of the mechanical parts, the sensors, the actuators, and the components work together to create a responsive environment and a monitoring system. They interconnect to the sensors are processed by a microcontroller, which then the actuators perform the appropriate actions such as adjusting air vents, opening and closing them, adjusting the temperature of the room, etc. Next slide. Like I said, the robot's designed to monitor and respond to the environmental conditions in a room, such as temperature and occupancy. It's a cylindrical body, about 100 centimeters tall, 50 centimeters in diameter, with a motion sensor, temperature sensor, and wheels to allow the robot to move around and collect data from various points in the room. The parts that I kept from my original design include the temperature sensor, which is used to measure and make sure everything's at an ambient temperature. The wheels, so it could move and collect data and respond to changes in the environment, and the overall shape and dimensions. The cylindrical form was simple, aesthetically pleasing, and easy for construction. The parts I removed were the LED lights, speaker, camera, microphone. They were all taken out of the final design. The LED lights were removed because they were unnecessary and added complexity to the design. I removed the speaker and microphone because of the cost and complexity to the design, and also it took away from the robot's core functions to monitor the environmental condition. And I removed the camera and the display also to reduce the cost and the complexity. And I wanted to make it accessible to multiple customers by keeping it simple, keeping it cost effective, and keeping the functionality straightforward, excuse me. Next slide. Here you can see inside the cylinder where it houses neatly all of the sensors, actuators, and the electronical components. Next slide. And so the Atmosphere robot's equipped with a few sensors. One, the PIR ultrasonic sensor. It uses that sensor to detect the presence of people in a room. This enables the robot to adjust its behavior based on the occupancy, ensuring that the efficiency is good and the energy conservation is considered. The temperature sensor is there is the key component of the robot. Measures the temperature of the room and allows the robot to this allows the robot to provide information on the current temperature and make adjustments to the environment, such as controlling to a connected thermostat or sending notifications when the temperature is outside of a predefined range. And then the servo motor. The servo motor is versatile and precise. It plays a crucial role in the robot's performance by controlling the movement and adjusting the air vents, ensuring a smooth navigation and efficient temperature regulation within the environment. So the Atmosphere robot's around $110, and the cost is the balance between affordability and functionality, making the robot accessible to a wide range of users. Next slide. Here on the circuit design, you can see the PIR motion sensor, the TMP36 temperature sensor, and the micro servo motor. Let's see, all these electronics work together to create a design that actually control the environment of the room and detect the motion and detect motion and temperature. Next slide. Following the logic, they're all intertwined and work together, but they are on a continuous loop where first the ultrasonic sensor monitors for motion. If there is motion, it'll initialize the other sensors and continue working in that loop. Next slide. The temperature monitoring starts by reading the temperature of the room. Is it correct? Is the temperature matching the correct setting that was made by the owner of the robot? Yes, it'll continue to follow that loop. If not, it will turn on any AC system to get to the right temperature. Next slide. And then the servo motors, it has the dual purpose. So one, moving to an open location. Is there any motion in the room? Yes, it'll stop and start initializing the other sensors, checking for temperature. And the checking for the temperature, is it correct? Yes or no? And it still opens and closes air vents to accommodate that temperature change. Next slide. Great, and I'll share my screen really quick. Excuse me. Great, so you can see on the TMP module, there's the temperature is being constantly checked as you adjust it up and down. You can see the temperature change. It checks for motion in the room. And you can see in the serial monitor, it's checking for constant changes in temperature. Great.
And finally, this is the intoxication testing robot. The purpose of this robot is to accurately detect a person's blood alcohol level as long as it's erratic behavior and movement. If your blood alcohol level is above 0.08, you're legally drunk, and that's the purpose of this robot, is to accurately detect how much blood alcohol you have in your system, as well as any key erratic movements that you have. Some of the key differences from my original design was perhaps using 4 robots instead of 1, just to utilize the ultrasonic distance sensor a little bit more accurately. Here's a parts list and a total cost for the robot itself. Some of the sensors and actuators are shown here, with key features being the gas sensor, which ideally would be an MQ3 alcohol sensor that measures the blood alcohol level, and servo motors and DC motors as well. Some of my mechanical design features here shown are the breathalyzer portion, where it simulates where a person breathes into, and distance sensors to accurately detect how far an individual is from the robot itself. LED lights to give a positive ID if you are intoxicated. And here's a mid-sectional view and top view of it. Here is the circuit design for my robot for the actuator portion and for the sensor portion with the Arduino code itself. Here's the flow chart that shows if a person is intoxicated and testing above 0.08, it would prompt the LED bulb to be activated. If not, then there would be no action required. Here is a simulation of that screenshot. Another flow chart that I would show is a testing range within how close an individual will get to the robot itself. If they come close within 2 feet of the robot, then the LED bulb would be activated. You can see this in this portion over here, where if a person crosses that threshold of 24 feet within the robot, it would trip the sensors and it would light, the LED bulbs will light up. And this is right here. This is a simulation of the code itself. And let's see. Share screen. Share. Here is the actuator portion of things, rotating 45 degrees for this motor, and a servo motor, and a DC motor itself to have the cylindrical portion to raise and heighten up to the level of a person. This shows how close an individual gets. If it gets closer to 24 inches of the robot itself, the LED light would light up on this side. And another simulation here is when a person breathes into the mouthpiece where the breathalyzer itself, the gas sensor would sense how much blood alcohol level you are. If you have above 0.08, the LED bulb would light up over here. Again, this is not a completely brand new design. We're strictly mimicking what an individual would do. The individual cost for the whole system for the BaRaBots would be $908. The average cost of labor nowadays for a work week for 4 individuals would be roughly about $4,000 on average. That would be a cost-saving alternative for bar owners, and it would cut down on human error by 50%. So we addressed most of the key needs by the customer by focusing on the need and efficiency and satisfaction as well. In conclusion, we supported evidence that a BaRaBots initiative will alleviate staffing issues, and its seamless integration will provide accurate data and would help the bar run efficiently and safely. As by allowing ourselves to be put on a customer's point of view, then we integrated solutions to address most of its concerns. Thank you very much.